Hello students, and welcome to the final video of section 2.4. In this video, we're going to be doing the analysis that connects f of x with f prime of x, the function with its derivative. And so we're going to look at how things are increasing and decreasing, relative extremes, and things like that. So let's get right into it. So there's going to be three problems in this video. In each of these problems, we're going to want to find where functions are increasing and decreasing and find all the coordinates, specifically the coordinates of the relative extrema. So in order to do this, we're going to want to find all the critical values. So what are critical values? Well, critical values are values of x at which a function has a potential maximum or minimum. So if you refer back to any of our other videos, we know maximums or minimums are occurring when f prime of x is equal to 0. So having said that, we know we need to find the derivative here. So f prime of x is going to be 3x squared minus 6. And so I want to take that and I want to set that equal to 0. So equals 0 right there. So 3x squared equals 6. Divide that by 3, so x squared equals 2, and then find that square root. So x equals the positive or negative square root of 2, which is like 1.4, I think, or something close to that. So how are we going to do this analysis where we're finding all the increasing and decreasing? If you think back to your pre-calculus days, we were making something called sign charts. So a sign chart, think about a number line, something like that, okay? And this is going to be values for f prime. And what I'm going to do is I'm going to put all the zeros that I found. So I have negative square root of 2, and I've got positive square root of 2. So those are going to be my zeros right there, okay? And so I'm going to substitute in values for my derivative, 3x squared minus 6, that are within these intervals. Let's think of a value that's less than negative square root of 2. Any value will work. I'm going to use negative 5. So x equals negative 5. And I'm going to substitute that in. So 3 times negative 5 squared minus 6. So I just substitute that into f prime. And so what I'm going to do with that is I'm going to worry only about the sign that comes out. So negative 5 squared is 25 times 3. That's 75 minus 6. So, okay, what comes out? I get a positive value. Now, that is going to be a positive value for f prime. Any value less than negative square root of 2, so like negative 2, negative 3, all the way to negative infinity, is going to be positive values for f prime. Now, in the middle part, I'm going to say, okay, let's pick a number. I'm going to use x equal to 0 here. So I'm going to go the same thing, 3 times 0 squared minus 6. So I'm going to get 0 minus 6, and I'm going to get a negative value in that case. And then lastly, I'm going to pick a number greater than square root of 2. So I'm going to use x equals 5, I guess, in this case, since I use negative 5 over there. And I'm going to substitute that in. So 3 times 5 squared minus 6, and I'm going to get another positive value out of that one. And so what you want to do, you want to think about, okay, what does that mean in terms of f prime? So when f prime is positive, what does that mean for f? Well, when f prime is positive, when f prime is greater than 0, we have functions that are increasing. When f prime is negative, they're decreasing. And when f prime is positive, we're increasing again right there. All right, so that's going to help us. This whole table is going to help us determine information about f. So we want to say first, f of x is increasing, and we want to get those intervals. So is moving from negative infinity. So where are those intervals where the graph is positive, where the derivative is positive? Because when the derivative is positive, the function's increasing. It's going all the way from negative infinity on my number line, and it stops going positive once I hit negative square root of 2. So negative infinity to negative square root of 2. And then I also have another point where I'm increasing. So union the square root of 2 all the way to positive infinity. So just like that. But we also have to have a justification for that. And the reason for this is because f prime of x is greater than 0. That's my calculus reason. Because when f prime of x is greater than 0, when it's positive, f of x is increasing. And we've done the analysis above to show that. But we still need to actually write out our reason for it. So now I want to say, okay, where is f of x decreasing? So f of x is decreasing on negative square root of 2 to positive square root of 2. All right, and the reason I know it's decreasing is because f prime of x came out to be less than 0. So I use the derivative, my calculus, to determine information about the function. I never graph the function. I'm using just calculus to analyze what's happening. So now I want to say, okay, where do we have a relative max? So f of x has a relative max at x equals negative square root of 2. And think about why I know that. So the reason why I know that is because f prime of x changes from increasing. So no, f prime of x changes from positive to negative there, which means that f of x is going from increasing to decreasing. That is a maximum that's happening. So now I want to find the coordinate of that relative maximum. So in order to do that, I need the y value, because I know the x value right now. So I need to find f of negative square root of 2. So I substitute that in, I get negative square root of 2 cubed minus 6 times negative square root of 2 plus 1, which comes out to be negative square root of 8 plus 6 square root of 2 plus 1. And if you type that into, go ahead and type that into your calculator right now, that's going to be approximately 6.657, which means that my relative max that I found, the coordinate for that relative maximum, is going to come out to be, negative square root of 2, which is approximately negative 1.414. And then the y value is going to be approximately 6.657. So on your AP exam, you only need 3 decimal points, but I always encourage you guys to go all the way up to 4 decimal points, just so that you don't get any rounding errors that might happen. But I'm not done here, because I still need to do another part. I need to say, where is f of x, where do we have a relative minimum? So f of x has a relative minimum at x equals positive square root of 2. And the reason I know that is because the derivative, the table that we made above, the sign chart, is that f prime of x changes. The signs change from negative to positive. All right, so then since I know it's going to be at square root of 2, let's find the coordinate. So f of square root of 2, I'm going to get square root of 2 cubed minus 6 times square root of 2 plus 1, which is going to come out to be like the square root of 8 minus 6 square root of 2 plus 1, which comes out to be approximately negative 4.657. Okay, and so the coordinate of my relative minimum that I found, so I always want to write that coordinate down, is going to be square root of 2 comes out to be approximately 1.414, and then my y value is going to be negative 4.657. So given the information that I've got now, I've got a very close relative minimum. I've got a very close relative maximum. I know where the function's increasing and decreasing. I can actually draw out a graph of this function very cleanly by hand because I've done all the analysis, I've done all the work using calculus. So now I want to answer all the same questions here in problem 2. And so again, I want to find the critical values. So I'm going to start off by finding, okay, what is f prime of x going to be? And that's going to get me 15x to the 4th minus 15x squared. And so what I notice here is that I can set this equal to 0. So 15x to the fourth minus 15x squared equals 0. And then what I see is that I can factor here. So I can factor out a 15x squared, and I'll have x squared minus 1 left over equals 0. That can actually get factored again. So let's see what I have now. So I got 15x squared, and then I have x plus 1, and I have x minus 1 equal to 0. And let's set each of those three factors equal to 0. So 15x squared equals 0, x plus 1 equals 0, and x minus 1 equals 0. So, all right, what's happening here is that I solve for each of these, and I get x equals 0, I get x equal to -1, and I get x equal to +1. So just like I did last time, I want to go ahead and I want to make my handy dandy sign chart. So this is going to be my sign chart for f prime of x, and I want to put in all three of the zeros that I found. So the first one I found is -1, and then I got a 0, and then I got +1. So those are going to be my three zeros, and then I want to substitute in values in between each of those. So a value less than -1, let's just use x equal to -5. And I'm substituting it in up here. I'm gonna use that function right there, and I'm gonna only worry about the signs. So if I substitute -5 into 15x squared, well, that sign that's coming out is going to be positive. Then if I substitute -5 into x plus 1, I'm gonna get a negative. And then if I substitute -5 into x minus 1, I also get a negative. So positive times a negative, my end result is going to be positive, which means that f is increasing. So now I'll use a value in between -1 and 0. So I'll just say, okay, x equals -1/2. You could use another value if you want. And then I just see what happens. So -1/2 squared times 15, I'm gonna get a positive. -1/2 plus 1, I'm gonna get a positive. And then -1/2 minus 1, I'm going to get a negative. So positive times negative, I get a negative result in the end, which means that my function will be decreasing. So now I'm going to use a value in between 0 and 1. I'll use x equals +1/2. And so if I use 1/2 squared times 15, I get positive value. 1/2 plus 1, I get a positive value. And 1/2 minus 1, I'm going to get a negative value. So overall, this all comes out to be negative, which means my function will still be decreasing. And once more, a value greater than 1 is going to be x equal to 5. That'll work. And so 5 squared times 15, I'm going to get a positive value. 5 plus 1, I get a positive value. And 5 minus 1, I get a positive value. So positive times positive, it all comes out to be positive here, and which means my function is increasing. So let's say, all right, f of x is increasing. So the chart that I made is never going to be enough. I have to always use calculus reasons. So we can see where it's increasing. So it's increasing on -infinity to -1. Union 1 to infinity. So we can see that it's increasing there, but we have to say why, because f prime of x came out to be greater than 0, came out to be positive. And now I'm able to say, all right, where is f of x decreasing? So f of x is decreasing on... So where is it decreasing? So I want to use each of the sections. So -1 to 0, union 0 to +1. So both of those sections that I've got there. And again, what's my reasoning for it? Because f prime of x came out to be negative, less than 0 here. So now I want to find any relative maximums or minimums. So I know that f of x has a relative max at x equal to -1. The reason why I know that is because the graph, or the f prime of x is changing, because f prime of x changes from positive to negative. So that f is going from increasing to decreasing. So because f prime of x changes from positive to negative. So since I know the x value now, I can find the exact coordinates. So let's find f of -1 using my original function. So that's going to be 3 times -1 to the 5th minus 5 times -1 cubed, which is going to get me, -3 plus 5, which gets me 2. So my relative max that I found, the relative max is going to be, my x value is -1 and my y value is going to be +2. And so we'll do a similar thing. So f of x has a relative minimum at x equals +1. And the reason we know that is because f prime of x changes from negative to positive. And since we know f prime is changing from negative to positive, we can say that f of +1 is going to be 3 times 1 to the 5th power minus 5 times 1 to the 3rd power, which we get 3 minus 5, which is -2. So my relative min in that area is going to be +1 for my x value, and my y value is going to be -2. So you might come back up to this chart up here, our handy dandy sine chart, and you might be looking here at the point 0. Well, why didn't we include that? Well, think back to why nothing's happening here. We are going from decreasing to more decreasing. So it's going down to more down. All right, so at no point is it going from decreasing and it's switching. We're only looking at where the graphs are switching signs, either from positive to negative or negative to positive. So now we have the final problem. This one's going to be a trig problem, and we're only going to be looking on the interval from 0 to 2 pi. But none of the work that we've done so far is going to change. We still want to find the critical values, but now we only want to care about the critical values between 0 and 2 pi. So let's start by finding f prime of theta, and that's going to get me 1 plus 2 cosine theta. So you really want to know the derivatives of sine and cosine and the other 4 main trig functions. And so we're going to set this to 0. So 1 plus 2 cosine theta equals 0. And so then I'm going to get, subtract that over to the right side. I'm going to get 2 cosine theta equals -1. Let's divide that by 2. So I'll get cosine of theta equals -1/2. And let's just keep that going right there. So in order to solve for theta, we're going to use the inverse cosine. So inverse cosine of -1/2. And where on the unit circle is cosine coming out to be -1/2? Well, that's going to happen in quadrants 1 and quadrants 4, where cosine is positive, and that's going to happen at 2 pi over 3. So, oh, sorry, I'm only looking at where it's negative. So when is it -1/2? So then that's happening actually in quadrants 2 and 3. And so then that's going to get me theta equal to 2 pi over 3 and 4 pi over 3. All right, so the same thing, we want to keep our handy dandy sine chart going. So let's draw that out. And this is going to be f prime. And keep in mind that we're really only going from 0 to 2 pi. And so we're putting in, so this is not negative infinity to positive infinity this time. And so let me put in my zeros that I just found. So I found 2 pi over 3 for my first critical value. And my second one came out to be 4 pi over 3. All right, so when I find these, let's use a value in between 0 and 2 pi over 3. So I'm going to say, okay, x equals pi over 2. And I'm going to have 1 plus 2 cosine of pi over 2. Well, again, I don't really care about the exact values. All I care about are the signs. So cosine pi over 2, that's 0. So I get 1 plus 0, which is a positive value. Now I'm going to choose a value in between 2 pi over 3 and 4 pi over 3. So I'll get x equal to pi. That seems pretty good. And so I'm going to substitute that in, 1 plus 2 cosine of pi. And again, I only care about the value. So 2 cosine of pi, so that's 2 times negative 1. So I get 1 minus 2, which is going to get me a negative value. And then lastly, a value in between 4 pi over 3 and 2 pi. I guess I could use x equal to 3 pi over 2. And so again, substitute that in, 1 plus 2 cosine of 3 pi over 2. And let's see what happens. I'm going to get 1 plus 2, cosine of 3 pi over 2 is 0, so I get 1 plus 0, which is going to be a positive value. So just like we did in the last two problems, we want to find where is our function increasing, decreasing, and maximums and minimums. So our first part is, where is it increasing? Well, that's going to be where f prime is positive. So I want to say f of theta is increasing on 0 to 2 pi over 3 and 4 pi over 3 to 2 pi. The reason we know this is because f prime of theta is greater than 0. And conversely, f of theta is decreasing on 2 pi over 3 to 4 pi over 3. The reason we know that is because f prime of theta is less than 0. So let's keep things going, finding the relative maximum and minimum. So from our chart where things are changing from positive to negative, we know that f of x has a relative max at x equal to 2 pi over 3. The reason we know that is because f prime of x changes from positive to negative. All right, so let's figure out that exact value. Let's find f of 2 pi over 3 so we can get the y value of our coordinate. And that's going to get me equal to 2 pi over 3 plus 2 times sine of 2 pi over 3, our original function there. So let's simplify that. So I get 2 pi over 3 plus, well, 2 pi over 3, sine of 2 pi over 3, that's going to be the square root of 3 over 2, but I'm multiplying that by 2, so those 2's divide out, so I get plus the square root of 3. So my relative maximum here is going to be my x value, which is 2 pi over 3, comma my y value, which is what I just found right there, and we can write that expression in there. 2 pi over 3 plus the square root of 3 in the end. So that's going to be my relative maximum. And now finally, we're ready to find our relative minimum. So f of x has a relative minimum at x equals 4 pi over 3. The reason we know that is because f prime of x changes from negative to positive. I know it seems like a lot to write each of these times, but again, know that you're going through this entire process and you really want to ingrain yourself into these justifications. So since I know that at x equals to 4 pi over 3, since I know that's a relative minimum, let's find the exact coordinate for that. So we'll find f of 4 pi over 3. And so that's going to be 4 pi over 3 plus 2 times sine of 4 pi over 3. And let's see, from that I get 4 pi over 3. So sine of 4 pi over 3 is negative square root of 3 over 2. We're going to multiply that by 2 and I'm going to get minus square root of 3. So what happens is that we found that our relative minimum, the coordinates for our relative minimum here, are going to be 4 pi over 3, comma, the expression that we just found there, which is 4 pi over 3 minus the square root of 3, just like that. And that is finally going to conclude this lesson on 2.4. If you're struggling writing out these justifications, trying to keep everything in order, you really need to practice these skills closely. So follow through on that homework. Make sure you're getting that complete. If you do need any help, you guys know I'm here to help you. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.